Hey everyone, and a massive, warm welcome back to the channel. It is truly wonderful to have you here with me today. Before we dive into today's fascinating topic, I want to take a sincere moment to send my very best wishes to you and your loved ones. I genuinely hope you are feeling happy, healthy, and full of positive energy. Wherever you are in the world, please take care of yourself and those around you. Now, let's explore one of the most incredible properties of our natural world, a phenomenon that transforms the ocean into a superhighway for sound and creates an entirely different sensory reality for marine life. I'm talking about the amazing fact that sound travels about 4 times faster in water than it does through the air we breathe here on land. This might seem completely counterintuitive at first. After all, water is a dense, heavy liquid, while air is light and gaseous. Our everyday experience might suggest that moving through something thick and dense would be more difficult and therefore slower. But when it comes to sound, the opposite is true, and the reason for this reveals the beautiful physics behind how sound actually works. Sound isn't a physical object traveling from one point to another. It is a wave of energy, a vibration that moves through a medium by causing its molecules to bump into each other. Think of it like a domino effect or a wave moving through a crowded stadium. The people don't run across the stadium, they just bump into their neighbor, who bumps into their neighbor, passing the energy along. The speed of that wave depends entirely on how easily those molecules can bump into each other and transfer that energy. This is where water's secret power comes in. In the air around us, the molecules of nitrogen, oxygen, and other gases are spread out and moving around wildly with lots of empty space between them. When a sound wave passes through air, it takes a little bit of time for one fast-moving molecule to find and collide with another to pass the vibrational energy along. It's a bit inefficient, like trying to pass a message through a crowd where everyone is spaced far apart. Water is a completely different story. The molecules in water are packed incredibly tightly together. They are about 800 times denser than air molecules. Because they are so much closer to each other, the vibration, the bump, can be passed along almost instantly from one molecule to the next. The energy transfer is far more direct and efficient, like passing that same message through a crowd where everyone is standing shoulder to shoulder. The closer the molecules, the quicker and easier the energy travels, and the faster the speed of sound. Let's put some real numbers on this to make it clear. Here on the surface, at a comfortable room temperature of about 20 degrees Celsius, sound travels through the air at approximately 343 meters per second. That's already incredibly fast, about 1,235 kilometers per hour, or 767 miles per hour, which is faster than a commercial jet airliner. But in water, that speed jumps dramatically. In fresh water, at that same temperature, sound travels at about 1,480 meters per second. That is over 4 times faster. In seawater, which is what fills our oceans, it's even quicker, moving at around 1,500 meters per second. This is because the salts and other minerals dissolved in seawater make it even denser, creating an even better pathway for those molecular vibrations to race through. This is why a whale's deep, low-frequency call can be heard by another whale hundreds, even thousands, of kilometers away. The sound loses very little energy as it zips through the deep ocean channels. This principle doesn't just stop with water. If you think water is good, solids are the absolute superstars of sound transmission. This is why the old trope of a cowboy putting his ear to a railroad track to hear an oncoming train long before he could hear it through the air is based on real physics. In a solid like steel, the molecules are locked into a rigid, incredibly tight structure. The bonds between them are extremely strong. A vibration in one part of the metal is transmitted almost instantly to another part. Sound can travel through steel at about 5,100 meters per second, which is roughly 15 times faster than it moves through air. Even your own body demonstrates this. The sound of your voice is conducted through the bones in your skull to your inner ear, which is part of the reason your voice sounds so strange and different to you when you hear it on a recording. You're missing the bone-conducted part of the sound you're used to hearing internally. This property of sound is not just a cool trivia fact. It is the foundation of critical technology that we use every single day, and it is essential for the survival of countless marine animals. Sonar, which stands for sound navigation and ranging, is the perfect example. A ship or a submarine sends a focused ping of sound down into the water. That sound wave races through the water at that incredible speed of 1,500 meters per second until it hits an object, like the seafloor, a shipwreck, or another submarine, and then it bounces back as an echo. By measuring the incredibly short time it takes for that echo to return, and knowing the exact speed of sound in that specific water at that temperature and salinity, a computer can calculate the precise distance to the object. This is how we map the ocean floor in stunning detail, locate sunken historical treasures, and navigate safely through dark, murky waters. Marine animals have been using their own biological version of sonar for millions of years. Dolphins, whales, and porpoises use a sophisticated form of echolocation. They produce a series of clicks and whistles that travel rapidly through the water. By listening for the returning echoes, they can build a detailed mental picture of their surroundings. They can determine the size, shape, distance, and even the internal structure of objects, allowing them to hunt for fish in complete darkness, navigate through complex coral reefs, and avoid predators. Bats use a similar system in the air, but because sound travels so much slower in air, their world of echolocation is much smaller and more immediate. In the ocean, thanks to sound's high speed, the range of this sensory perception is vastly greater, allowing for communication and perception over enormous distances. This also creates a unique and challenging environment. Because sound travels so far and so fast in water, the ocean is a very noisy place. The natural sounds of rain on the surface, cracking sea ice, underwater earthquakes, and the songs of whales create a constant background symphony. However, human activity has added a new, and often damaging, layer of noise to this environment. The low-frequency rumble of massive container ship engines, the intense pulses of air guns used in seismic surveys for oil and gas, and the sounds of sonar itself can travel for hundreds of kilometers. This human-made noise pollution can mask the sounds that marine animals rely on to find food, navigate, find mates, and avoid danger. It can cause them stress, displace them from their habitats, and even cause physical harm. Understanding how sound behaves in water is therefore not just about curiosity. It is also about responsibility and finding ways to protect the delicate acoustic environment of the ocean and its inhabitants. So, the next time you take a swim, remember that you are immersing yourself in a world where sound is the dominant sense. You are entering a realm where a splash can be heard from miles away, where creatures communicate across entire ocean basins, and where a whisper can travel faster than a speeding bullet. It's a hidden world of vibration and energy, a testament to the incredible properties of the most common substance on our planet. This simple fact, that sound travels 4 times faster in water, opens a window into a completely different way of experiencing the world, one that is both awe-inspiring and humbling. Thanks for joining me on this journey into the physics of our planet. Take care, stay curious, and I'll see you in the next video.